Welcome back. In the last video, we created Food Vision Mini model.py, and this is what's going to define our model instance, our FNet B2 feature extractor, because in the previous video, we moved our save model file there. So now let's create app.py, which is going to be the brains of our application, and it's going to be the default application that Hugging Face Spaces tries to run to create this demo. So you might have already given this a shot, but let's now do it together. 8.7, this is so exciting. We are creating our Food Vision Mini app as a deployable app, not just a demo in a notebook, a deployable app. Our Food Vision Mini Gradio app into a Python script. And now truly this app.py is not going to have anything revolutionary. We've already done the major steps. So let's break it down. It's going to have 4 major parts. The app.py file will have 4 major parts, and this is just tying everything together. So number 1 will be imports and class names setup. So we need to import some basic functionality, our dependencies for our app, as well as set up the class names. Now, again, class names we've already got in a variable. We just have to make sure we put that into an app.py so it can be referenced. Number 2 is going to be model and transforms preparation. So this is just going to be utilizing this function here. So our model is going to load in using create FNet B2 model, our FNet B2 feature extractor instance will be created by that, and the transforms. We're going to load our model in by loading in this saved state dict over here. Then number 3 is we need a predict function. So this is predict from above. Now truly this could be any function. We've just called ours predict, but that's the Gradio. This is our interface. If we look into the documentation interface, this is just our function. So a callable function. And you can really put this as almost anything you want. We've just called it predict because we're going to pass our Gradio interface an image, and we want some outputs in the form of a label, which is what our predict function does. It maps our inputs to our outputs. So that's going to be number 3, and we've done that just up here. So we want this function, predict, pass it an image, get back a dictionary and a prediction time. And then finally, number 4, what do we need? Well, we need the actual Gradio app. So Gradio app, this is going to be our Gradio interface plus launch command. Because after all, once we finish writing app.py and upload that to a Hugging Face space, Hugging Face is going to try and run that app.py, and the launch command is going to launch this app. So let's see this in practice, hey? I'm going to start off by writing the file. I like to live dangerously here. Let's, whatever we write in this cell is going to be written to file. So Food Vision, better make sure the file path is correct, hey? Food Vision Mini app.py, beautiful. And so we want to write it into here. What do we need? Imports and class name setup. Well, you might not know, here's the thing, you might not, and in fact, I'm going to comment this out so I get the Python formatting to begin with. 1 is imports and class names setup. So here's a little tidbit, is that I sometimes and quite often miss out on different imports because I forget what my code needs. So sometimes the only real way you can know the imports that you actually need is to try and run your app. And if it doesn't run, well, then you're probably missing an import. But I only know these ahead of time because, again, this is a machine learning cooking show. I've cooked these dishes up well ahead of time. So from model import, this is one that you might forget. So from model import, the reason we're importing from model is because app.py is going to live inside Food Vision Mini. And so from model import create FNet B2 model is importing from model.py. So that's a little hard to know ahead of time. I only learned that through trial and error. So don't worry too much if you make mistakes here. It's all about experimentation. So we're going to import the timer so we can time, And then from typing, I'm going to import tuple and dictionary. Wonderful. And then I'm going to start by setting up the class names, and that'll be section 1. How good is that? So I'm just going to do it nice and simply. I'm going to hard code it as a list. We could, if we had more classes, maybe we would save them to a file and import them. And in fact, no spoilers, but we might do that later on when we build a bigger demo. But let's now move on to section 2, and that is model and transforms preparation. So here's where we're going to leverage our create fnet-b2 model function from model.py. Remember, this app.py script is being written in the context of the Food Vision Mini directory, not any other directory from within inside this directory. That's demos, Food Vision Mini, app.py. It's not there yet, but it will be. So let's go model and transforms preparation. And we'll go fnet-b2 and fnet-b2 transforms, just in the same style that we've been using. We'll go create fnet-b2 model, and then we'll set num classes equals 3. We don't have to, because that's going to be the default. If we look at model.py, num classes equals 3 is the default, but we'll just do it anyway. We could also use something like this, because we've hard-coded our number of classes, or our class names, length class names. There we go. But I'm just going to put as 3. Beautiful. Now, what's next? Well, we need to load the saved weights. So this is going to be, again, within the context of this directory. This is our weights path, our state dict. So that's the file that we want to load in. How can we do that? Well, let's see. We want to go fnet-b2, which is the model that we just created above. Then we want to go load state dict, and then we want to pass in torch.load, and then we pass in the file path with f to this. However, if I copy this path, I'm going to put it in here, we get it within the context of Google Colab. So I actually want to delete all of this and only pass it in within the context of the Food Mini directory, because app.py is again going to live within this directory, so we can just straight away call this file path there. Again, I only know that ahead of time because I've been burned a few times. And then this is another one that we haven't worked with before, but we want our model to run on the CPU. So a little tidbit is that if we saved our model state dictionary after training on the GPU, it might by default think that we want to load it back onto the GPU. So this is where we hard code it to go, hey, you know what? When you load in this state dictionary, load it to the CPU. So load the model to the CPU. Again, if you don't do that, you might get some errors if you don't have access to a GPU where you deploy your Gradio application. So let's go to step number 3. What are we up to? Predict function. Oh, this one's a breeze. We've already got this ready. So predict function. Let's go, oh, $, because once we deploy Food Vision Mini, we can sell it and ride the money straight to the top. Or maybe we have to make it a bit better. We're going to find our predict function. Here we go. This is what we want. We can almost copy this directly into the app. And in fact, we're going to find out later if we can't and we have to update it. But let's just copy that in there. We've already done that. We've already imported that. So do we have everything? Timer, yes we do. fnet-b2 transforms, yes we do. fnet-b2 eval, yes we do. Predprobs, timer, I think that's it. Predict function, done. So this is just mapping again our inputs, which is an image, to our outputs, which is a prediction dictionary and the number of time, or the time that it took, so that we can get this rich output over here, so that we have something nice and pretty with stake and the prediction probabilities and how long it took. We've got one more step to do, and we've almost done this step as well. So let's come up here. We need step 4. We'll come down. This is step number 4. We have our Gradio app. So let me write this down. We want Gradio app. Now there's one thing missing from this. So this is just the exact same app that we want to run as before. But what are we missing? In the context of just this app.py script, it might not be immediately obvious, but if we want our example list to load, well, we need to load in those examples from this example directory rather than just the example list variable that we have. Oh, example lost. Yeah, they are definitely lost because we don't have access to them in app.py. We need to create this in this app demo. So, or app.py file. So let's go here, create example list. And how can we do that? Well, another thing that we've prepared earlier. We've already got it here. Example list equals examples plus example, for example, in OS list directory. This is the one thing that we won't have in app.py. We'll bring it down here, create example list. Oh, example list. What don't we have? We don't have access to this. So what can we change it to? Well, it's just going to be examples. So if OS lister is going to list the context of examples, this is going to be this examples directory because app.py is going to live in the context of Food Vision Mini. So there we go. I believe we've got everything we need for app.py. And of course, we're going to find out if we don't. There we go. We're going to find out if we don't when we try to deploy it, and then we can fix it on the fly. So app.py. There we go. So we've got our beautiful Gradio demo that we can upload to Hugging Face Spaces in 72 lines of code. And truly, we could reduce this if we wanted to. We're being a bit verbose, but that's on purpose. So what do we have left? Let's go back up to our little file structure tree. We've done model.py, done examples, done app.py, done saved model. We just need requirements.txt. Now, what is this going to be? Well, when Hugging Face Spaces tries to deploy our app, it's going to try and import a few things, but it won't necessarily have those dependencies such as Torch installed. So requirements.txt is going to tell Hugging Face what dependencies to install when we try to deploy our app. So you might want to go ahead and give it a shot of creating requirements.txt. We're going to need 3 things. So I'm going to write down here. What are we up to? 8.7? 8.8. Creating requirements.txt. We need 3 major things. That is Torch, Torch Vision, and Gradio. So give that a shot. If you want to look up how to create a requirements.txt file, how can you do that? Well, you can search create with Python. A whole bunch of great resources there. So give that a shot, and I'll see you in the next video. We'll create the final piece of our puzzle for our Food Vision Mini demo app. I'll see you there.